Alright, so this video is just going to go over what we did in class regarding the kinetics lab, um, just to try to get you caught up with where everybody else is. You should already have all the times filled in for your table 1 and table 2, and once we finish with this video you should be able to fill in the reaction rates for I minus and I3 minus for both tables, as well as the concentrations initially of each of the reactants for experiments 1 through 9. Alright, and we're going to do that by going down and looking at the questions. Notice it does say you want to show an example for each of these calculations in parts 1, 2, and 4 for experiment 1, and then you need to show all the calculations for part 3. That'll make sense once we get there, and the sig figs apply. You want to make sure you include them, and units as always, where appropriate. So question 1 is basically asking us what was the concentration of the reactants when we added them all together. Because we added certain amounts of each stock solution, but when they were mixed together, similar to what we did in lab today at the equilibrium lab, we had to account for the fact that there was a greater volume present. And so I went ahead and showed you what it would look like for experiment 1 for hydrogen peroxide. And I'm getting my values from this procedure table. If you look here, you see the stock concentration of the different components, the H2O2, the HCl, and the Ki, and you see the volumes of each that you added. And no matter which row you look at going across, you should always get the volumes to add up to be 100. We adjusted the water volume depending on the amounts of those reactants we used. So if I go back to that question, we used 10 mils of 0.01 molar hydrogen peroxide to prepare the 100 ml solution. So the new concentration of hydrogen peroxide before the reactants start to combine together would account for M1V1, the concentration times the volume, divided by the new volume V2, and that would give us our M2, 0.001. So anytime hydrogen peroxide has a volume of 10 mils, over here in our table 3, we would put 0.0010 molar for the H2O2 concentration. So you're going to go through and do that for H2O2, HCl, and Ki, which is going to serve as our source of I minus. So I think we did that the lab before you left, but that was what was due for homework for last class. So make sure you get that done for tomorrow. And then we also talked about how you could calculate the rates of appearance and disappearance based on your concentrations, which is why I needed you to do them before you could do part 2. So you're going to calculate the rate of disappearance of I minus for each experiment. That was when we saw the color change occur. And so if we go back and look at I minus in experiment 1, we see we used 10 mils of 0.05 molar Ki. That's going to be our source of I minus. And since we had 100 mils of solution, that's going to cause the concentration to decrease from 0.05 to 0.005. We would take that concentration and divide it by the time for experiment 1 to get the rate of I minus for each of those experiments. And that's what we're going to fill in back in our data tables for the change in I minus concentration over the change in time. I3 minus is going to be determined from that I minus rate because according to the balance equation back in the introduction, we saw that you needed 3 I minuses to make 1 I3 minus. So the rate of I3 minus would be basically a third of the rate of I minus. So what you get for your answers for number 1, you would do stoichiometry to convert between I minus and I3 minus, and that would give you roughly a third of the rates that you would got for your I minuses, and those would be placed in this last column. Alright, and so we will continue working on this lab in class tomorrow, but the more of that you can get done prior to lab, the better off you'll be for lecture.